done extensive research on the water quality of the Escondido Creek watershed around this area, specifically pertaining to the southern steelhead trout. But I will let him dig under that. You're welcome.
Thank you. Thanks for coming out. I'll give you a little brief history of why I think steelhead deserve to be back in the creek again. I'm actually from Canada, near Toronto, on the Great Lakes. I grew up as a Great Lakes guy, and I did my master's degree on rainbow trout. Southern Ontario is a huge rainbow trout culture area. That's the main fish species there is. I did my undergraduate degree in fish biology, but I specialized in aquaculture. And then I did my master's in trout and reproductive physiology. So I've always been sort of a trout guy. So I moved to Southern California, and then we moved to Elfin Forest. And I see the Escondido Creek, and it's like, holy cow, that creek needs fish. It needs rainbow trout in it. And then I finally learned that the steelhead trout are originally from Southern California, and I'll discuss that a little bit more here as we move along. So I kind of got involved with the water quality testing because, of course, one of the key features of any sort of water body is the quality of the water as to whether it would sustain fish or not. So Kevin Bernard, who has been a huge instigator and member of tech for many, many years, he and I put many grants together of money to try and build a hatchery. So the main long-term goal that I sort of envisioned was building a rescue hatchery for southern steelhead. And it would have been fantastic, but it ran into many, many roadblocks, partly because it would cost about $2 million to build even a small hatchery. I think Ariel said she's got some money that she might be able to.
I don't have any money.
If anybody's got an extra like $2 million they wanted to do something really neat with, a steelhead hatchery would be awesome. Anyway, so let's move on here. So I'm going to talk about like who is the steelhead trout? Well, what is this sort of mystical fish in Southern California? Why is this creek so important? Because it is a unique creek, and I'm guessing many of you understand how unique this ecosystem in this creek is. And then, what is water quality? What are the things that we were testing, and why did we test these things for so many years? So the steelhead is actually a variant of a rainbow trout. A steelhead trout is really a rainbow that goes to seed. So typically the fish will come in, they're just sort of like Pacific or Atlantic salmon. They come from the ocean, they come upstream, they spawn, they go back to sea again. Well, unless you're a Pacific salmon, you die. But if you're a rainbow trout or an Atlantic salmon, you go back to sea again. So that's essentially the steelhead is a rainbow trout. And one of the unique things is that they think the rainbow trout may have originated from Southern California and into Mexico, which, if you think, there's rainbow trout all over the world. It's one of the most popular trout that you'll find stocked, cultured, all over the world. So it kind of blew my mind to think that all these rainbow trout that are everywhere have essentially evolved from the fish that we have here in Southern California, which there's probably maybe half a dozen left. We've done a really good job of terminating them. So that's pretty remarkable. Our strain here is pretty unique. Rainbow trout and most salmonids are incredibly intolerant of warm water. And if there's one thing that we get in Southern California is warm water. So our southern steelhead have evolved to be much more tolerant of temperature and other water quality issues. I'll show you the range and what's threatening the species. You know, we have habitat destruction and things like that we have to deal with. So a rainbow trout is a member of the salmonid family, so it's related to the chars like Arctic char, lake trout, brook trout, the salmon, all Pacific salmon, Atlantic salmon, and also the trouts like brown trout. They're carnivorous, so they feed on small fish, crustaceans, and insects in the streams. They're also one of the most primitive fish, and this little fin here at the top, that's sort of indicative of being a primitive fish. It's called an adipose fin. If you look at bass and things like that, they don't have adipose fins. The salmonids all have adipose fins. And in general, most of the salmonids, including rainbow trout, are very sensitive to poor water quality. So like our creek here is full of largemouth bass and green sunfish, and they're pretty tolerant of poor water quality, whereas the rainbow trout are less so. So that's one of the reasons that we need to test the water quality and look at it over a long period of time to see if it's suitable for these fish to re-inhabit this area. So these are some examples of different salmonids. So at the top you've got a lake trout, so that's a char. Then you have a coho salmon, and then a rainbow trout, and then at the bottom you've got a Chinook, a small Chinook salmon. So you can see they all look pretty similar, and they're all in the salmonid family. So here's the range of our southern steelhead. And so it goes all the way down into Mexico, and they actually think that there are still resident populations of southern steelhead in the mountains in Baja California, which I don't know who's gone looking yet. I think it would be really interesting if somebody can get to some of those headwaters in the hills down there. But I've heard that there are some fish still remaining down there. So how did the rainbow trout get from here to everywhere else, apart from being transported in trucks? So they think that during Ice Age, there's going to be a lot of water everywhere, so there's these migrations of fish that would have moved all over the place. So that's one method. And then, of course, people put them in trucks and drive them and fly them in airplanes and things like that, which is not necessarily a good thing in all instances. And then what's happened here? So one of the problems that our fish have seen, the southern steelhead, we have all these wildfires that are more intense now than they have been in the past. Now, we all know that before man ever lived here, there were going to be wildfires ripping through here all the time. But back then, too, also, many of the streams and creeks would have had more water in them, but also we would have had resident populations living out in the ocean. So between the more destructive wildfires we have, but also because of everything we've done. We've taken these creeks and streams that would have harbored fish, and they're dry now. They don't have the same sort of access to come up and spawn as they used to. So because of man's impact on these animals, there's just very few places for them to come and spawn. And there's no animals left to come back, very, very few. I mean, they've been finding small groups of animals in headwaters. The Sweetwater Creek, I believe, has some, and what's the creek that goes through Camp Pendleton? Santa Margarita. Up in the headwaters of the Santa Margarita, they have some steelhead there, they think, as well. So there's a few like little small resident populations that they found. But with these wildfires, it wouldn't take much for a fire or two to rip through there and just decimate them, because these streams, they don't flow all year and they're trapped. So a few years ago, when there was a fire that was threatening one of these populations, they went in and took the fish out and put them somewhere where they would survive. Whether they put them back or not, I don't know. That's where the hatchery comes in. You build a nice hatchery, you can bring the fish in, you can spawn them, and then start repopulating again. So that $2 million.
Write it down.
So why is the Escondido Creek important? I mean, at least from what I've seen, it's one of the few creeks in Southern California that flows all year round. Now, granted, some of that is runoff from Escondido, but I do believe there's quite a bit of like spring water that is coming into the creek as well. Because even during heavy drought times, and if you drive up through the, what road is that? Right where the Escondido Creek enters Escondido, you can look at the drainage ditch and you can kind of see how much water's coming through there. And there's been times where I've seen not a lot of water coming through that ditch, but once you get down here, there's still quite a bit of flow. When I was doing lots of water quality testing, I was much more in tune as to the flow rates in the creek. So I did see big differences between what was actually running off and what was in the creek. Because even where I live off of Sequest Trail, and there's a couple of springs through there. Like one of our neighbors had an artesian well and a spring on their property, and there's this little tiny tributary that runs into the creek, and even during the times of extreme drought, it still kept flowing. So there is some water that is getting into the creek that's not just runoff. So the Escondido Creek provides a really nice natural environment too. So I'm kind of getting ahead of myself. So here's a picture, looks like a pristine creek. I mean, between Escondido and the ocean, the Escondido Creek can provide some pretty pristine environments for fish, especially with all the invasives that have been removed and a lot of the natural vegetation's coming back in. Because what you look for in a trout stream is like a canopy like this. And then you'll have areas of still water and areas that are moving more like that. And those are what a typical trout stream is looking for. So this is actually a hatchery that I worked at in Canada. So this is what I think would be the most useful for trying to get southern steelhead populations back. If they're hoping that 7 or 10 fish are going to turn into natural spawning populations here, they're kidding themselves. So they need to have some sort of reproductive program in place. These are actually brown trout eggs, the newly hatched Elfin. And those were eggs from my master's degree in that top corner. So the water quality, as I was saying, is very important. So why did we pick certain parameters? So originally it started off, we were testing parameters that were important for the fish. So I actually managed fish hatcheries for many, many years. I managed a hyperstriped bass hatchery in Sorrento Valley of all places years ago. It was a commercial hatchery, and then I also managed the white sea bass hatchery in Carlsbad for 7 years. And we tested water quality daily on not just the tanks in the hatchery, but also the water coming in the building, so we knew what was going on and that sort of thing, so we could kind of guard against any changes. So that was the original plan. And Greg McBain, that's him here, in his waders, he was instrumental years ago when we started doing all of our water quality testing. He and I would do it once a month religiously, and we would actually do it over in that corner over there. And he was actually so good at organizing everything, organizing the data, and organizing me to get my butt out here and do some sampling. And but he was also interested in the water quality beyond just what would be good for the fish. He was the one that started looking into insect populations and how that can be an indicator of quality of the creek. So he actually took it even one step further and instigated some insect studies years and years ago. And Rick, is it, sorry?
Rich.
Rich now has more data, which I didn't know about, which I'm very interested in looking at.
Because from the water board.
Because what they do, if you look at insect populations in the creek, because there's lots and lots of different bugs that live in the creek. You know, a lot of insects will have aquatic stages in their life cycle. And that's why fly fishermen look at bugs all the time. And some of them are incredibly tolerant of lousy water, and some of them will die if you look at them skew. So there's this huge range, and if you kick the bottom of the stream, collect all the bugs that are down there, and identify them, they've got scales now to give you a health of the creek. So depending on what insect larvae they find, it tells you how good the creek is. And I think it was the stoneflies were like the most sensitive. So if you find stonefly larvae in your creek, you're doing a good job. So we never found any stonefly larvae back then. So
Rich.
We found one on a tributary, where it wasn't in the creek. Tributary coming off of the
Misha Creek.
Yeah, up near the top of the hill.
Okay,
They
Well,
did
that's-
find, and then also the entomologist found a Dobson fly, which is equally rare.
oh, and that's great.
Yeah, so those are tributaries that are seasonal, which means some years they never flow,
Right,
but still the larvae have a way to maintain viability even
right,
in
they
a drought.
insist in the bottom.
Mhm.
That's really good. Yeah, I mean, the creek, the biggest change in the creek when we were doing our water quality testing was when the chicken ranch went away. So, I don't know, how many of you remember the chicken ranch that was over there? Do you remember the cesspool? The big pond that was right next to the road? I mean, that was the nastiest bit, if you could call it water. It was just chicken manure that was leaching in there, and there had to have been leachate from that, even though there wasn't a direct connection to the creek from that cesspool. When that thing went away, when they did all the construction, our phosphorus and nitrogen levels plummeted. I mean, we used to have, when we were doing our phosphorus testing, we used to have to do a dilution by 10 times just to get within the readability of the spectrophotometer on the instrument. After it went away, we didn't have to do any dilutions. It was below the maximum tolerance just with a straight sample. So that was the most remarkable thing. And I figured that once that happened, we might start to see more of the delicate insect species. When was the last time they did bug kicks?
They're doing them every
Oh,
year.
yeah, we do them every week.
Oh, we do them here, but the water board is doing them every year. So some of the data that I have will have that.
We've been from last year.
Yeah.
Yeah, because when you do them here, are you identifying the insects too? Or
We are, but we're not doing any documentation, but
Okay.
we are looking at them regularly.
And it's pretty crude documentation, we're not like classically trained entomologists.
Yeah, we're at the family level, not the species
Yeah.
level.
Okay.
And so
Oh,
those
that's-
tolerance scores are at the species level.
Yeah, but like we were talking about counting the number of hairs on their 8th appendage is like, I mean, that's the difference sometimes in these species, right? So, and where are they doing the sampling? Because I would imagine that there's parts of this creek that are not going to be habitable by the sensitive bugs, but there are other portions where it's going to have a much better chance. Like down
We do it
at
right over here.
Betsy Keithley's property, do you know where the chevron, the concrete chevron is in the creek? That area is beautiful. I mean, I would imagine that if you were going to find more delicate insect species, that would probably be a good spot to check because it's farther downstream. There's shallow pooling with riffles. So I would think that that's a good spot to check. But it's another subject.
Paul, are you aware that our third graders do water testing and
Oh, really?
Ariel?
Where's that? Sorry.
Explain to Paul
What we
the
do?
third grade program with the insect.
Right, so we have all the third graders in Escondido Union come through.
Wow.
We've been having field trips all week. We have one tomorrow too. But we'll go out in the morning and we'll, scrub some rocks and gather a collection. And we try to get a pretty decent kind of depiction of what's in the big sample into petri dishes for each individual
That's really cool.
student. And they'll identify, but they have like 3 choices. It can either be a caddis fly, mayfly, or a black fly. And we talk about what that indicates for the health of the water.
That's so cool.
Yeah.
Awesome. How many squeals do you get?
Oh, yeah. A couple, yeah.
Occasionally.
Oh, that is so cool.
Yeah.
So there's the entomologists of the future.
All the third graders in the whole district.
Well, you could probably pick out that one's going to be an entomologist, right? So that last picture was pretty pristine. This one here, I always found very interesting. That's just a big pile of trash. And then this one is also pretty disgusting. And they're all the Escondido Creek. So this one is closer to Escondido. The trash was a little bit farther down, but it was still pretty close to Escondido. So as the water moves south, the quality gets better and better and better. Creeks and streams are very good at recovery. So, which always amazes me, and I'll kind of go over a little bit as we start talking about water quality parameters. But also, human intervention and getting rid of this stuff. And I know we have a pretty big homeless problem at the headwater, at the creek by where the drainage channel ends. There's a lot of homeless that live in there. And so a lot of the trash and stuff comes from there, and I wish they could figure out how to give these people a better place to pitch their tents than right at the creek, because the water they're drinking and bathing in and stuff's not healthy either for them. So they need a healthier place to be. So it is remarkable how a stream will heal itself as the water moves towards the ocean. So what do we test water quality? As I mentioned, rainbow trout are very sensitive to poor water quality, so if we ever wanted to put in a population, try and get a resident population back again, we have to ensure that the water is going to be adequate for the animals. And it has to be adequate so that they can reproduce. I mean, you don't want to stick fish in the creek. They may live, but if the water quality is sort of marginal, they may not reproduce, and that's definitely not going to get us anywhere. If we do have poor water, even if we stick fish in, they go to sea, they may not come back and be successful, so then we may not have residents. It's always good to have resident fish, because resident fish will actually be sort of a genetic reservoir. So if you have a population that goes to sea and for some reason they all get sick and die or something, the killer whales come up and they decide that these steelhead are the best thing to eat this year, then they're gone. So we've got this resident genetic pool of fish that live in these creeks. So that's why it's good to have a lot more healthy creeks along the coast so that you have these genetic reservoirs. Poor water quality can lead to deformities in the fish. So deformed fish generally don't do well in the environment. They become prey items, among other things. And it can also lead to disease and mortality if it's bad enough. So what affects the quality in our creek? So we get runoff from urban areas like Escondido, and a lot of that's through irrigation, runoff from rainfall. When we do get rainfall and runoff from irrigation, we're going to get organics from like fertilizers, pesticides, and herbicides that are used. We can get a lot of bacteria. There's going to be fecal waste and things like that that also encourage bacteria and other microorganisms. And then we get all that garbage too. We do get some inputs from the waste treatment plant now and then. I don't know. The HARF doesn't discharge into the creek regularly. It's just the emergency overflow, right? Yeah.
Right, they have, there is a website you can go to, and there was a release last January.
I bet there was with all that rain that we had. I don't think they had a choice at some point. I guess they're lucky that when it's raining that much, the creek is just a torrent. So anything they put in is minimal compared to normal flow rates in the creek. But that does have an effect on fish species as well. And then just runoff from the land, from the watershed. You're going to get runoff from decaying vegetation, animal waste, and those sorts of things. So those get into the creek too, but they're generally not as big of a problem as the runoff and whatever comes out of the city. So I'm just going to now talk a little bit about the parameters that we were testing and why we tested them. If you're a rainbow trout, the most toxic things to you in a contained environment, and it's the same for, who has an aquarium at home? No aquarists? Oh my God, I have aquariums for sale. You have an aquarium? So one of the biggest things for aquarium fish too is having a functioning biofilter. Now there used to be one over there with the aquaponics going on and all of that.
We are having power reliability issues, so
we're having fish reliability issues.
Yes.
So it's the same for your aquarium as it is for the wild environment, as it is for cultured fish in a fish farm when it comes to nitrogen. Ammonia is very, very toxic. So in a closed system, And I mean, I'd even consider our creek kind of a closed system, because whatever happens to the water is happening within that creek system. So it's getting rid of ammonia, and even nitrite's toxic, and nitrate is less toxic. So the process is taking ammonia, I'll get to that in a little bit. So ammonia, which is very, very toxic, it's probably the most toxic thing to aquatic organisms as far as nitrogen goes. So continuous exposure in a trout at 0.05 milligrams per liter, which is not a lot of ammonia, can be lethal. And it's the same with nitrite. It's highly toxic to aquatic life, and again, it's the same at 0.05 milligrams per liter of continuous exposure. It can be lethal. So what we want to do is to get to nitrate. And nitrate is good because it's essential for photosynthesis. So all the plants that are in the water, whether it's your aquarium or in the creek or wherever, are going to be pulling nitrate out of the water. And in natural streams, it's usually less than 1 milligram per liter. In an aquarium or an aquaculture system, it can be up like 8 to 10 or even more. But nitrate is not that toxic to fish. So that's why you want this conversion process to go from ammonia to nitrate, because it's not as toxic to the animals. And generally, it's either through absorption or through plants utilizing it, or you can have it bioconverted. There's bacteria. So when you set up a biofilter in your aquarium at home, it's the bacteria in that filter that are converting the ammonia and the nitrite into nitrate. So that's the important part, and that does happen in the creek. As we were measuring our water quality, we would generally see a decrease in the ammonia and nitrite levels as the water went downstream. So there was a conversion and a removal of those components from the system. I have that all written down and I forgot. I used to do this when I would teach too. I would get the slide up there and I'd start rambling for like 10 minutes, and then I'd go to change the slide and there's everything I just said. Come on, there we go. So dissolved oxygen, this is actually the next most important thing. In general, oxygen levels in a healthy system, like the creek, are generally not a big issue. Trout are very, very sensitive to low oxygen levels, and most of the salmonids are. They don't like anything really below 5 milligrams per liter. Now, things like carp and tilapia, they can go down to 1 or less, and they'll still survive. So trout are very, very sensitive, so that's why it's very important to measure the oxygen levels that we had in the creek here. And generally, we saw adequate oxygen levels. Now, oxygen is interesting in that as the water heats up, it will hold less oxygen. So if you took a flask or a beaker of warm water and a beaker of cold water, and then you put aerators in there and bubbled them like crazy, so you get the maximum amount of oxygen there, you would have way less in the warm water than the cold water. So what's interesting in Southern California and in Mexico is our water gets a lot warmer. So it's much more difficult for our water here to hold adequate oxygen levels for the fish. So I also do think that the southern steelhead has evolved to be able to tolerate maybe lower oxygen levels than other salmonids, just through evolution. So not only are we putting oxygen in the water, we're also getting carbon dioxide out. Because even in a closed system or in a stressed system that's got high carbon dioxide levels, it affects the fish's ability to extract oxygen from the water. Carbon dioxide at high levels actually acts like an anesthetic to fish. So you can put fish to sleep with high levels of CO2. And then nitrogen, getting rid of nitrogen is important because when we talk about water coming out of the ground, like springs and things, it often has very low oxygen and very high levels of nitrogen in it. And it can cause something called supersaturation in fish, and it can kill them. It causes bubbles to form in their bloodstream, and it can kill them. So stripping out nitrogen is also very important. So the way it happens is, like, this is a bubble, This was like a test question on when I was teaching, so everybody take notes. There's going to be a test at the end of the lecture. So what happens is if you have this bubble in the center here, which, and this is what I still find it amazing when you think of the ability of fish and aquatic animals to live in the water. Air has what percentage of oxygen? It's about 21%, right? Percent. Water has way less than 1%. Like we're talking, instead of parts per 100, we're talking parts per million. So these fish and their gills and the way they've evolved to be able to get oxygen from the water is absolutely remarkable. So because this air bubble has 21% oxygen in it, the oxygen is very rapidly leaving that bubble and going into the water because of the differential in the concentrations. But also usually too in water with high levels of carbon dioxide and nitrogen, those gases go into the bubble because there's not as much in the bubble. And that's how we do a lot of stripping, and that's how it does it naturally as well. Because if you, in a creek, so most really nice trout streams, they have these pools where the fish might, sit, but then you have these riffle areas. So where the water is all turbulent like that, that's like putting bubbles in the water. And that's what oxygenates the stream. So if you look at most really healthy trout streams, they have a pool and a riffle and a pool and a riffle, and that's kind of how they go. And that's how they maintain good oxygen levels. In a not very healthy creek, if it's just like a lot of still water, you're either going to have low oxygen levels or not a lot of fish, and it just can't sustain the population of fish that you would when you have these riffle areas. We also test pH, because pH is a good indicator of the water quality. The trout usually don't like it outside of the 6.5 to 8 range. pH is kind of a funny thing. In freshwater systems, it tends to fluctuate a lot because of rainfall. Our rainwater, it usually has a low pH, so if you get a lot of rain and it goes into the creek, whatever's living there is going to get exposed to a massive pH shift. And that's the really interesting about freshwater fish. In general, freshwater fish are exposed to much bigger swings in water quality just because they're in a lake or stream or somewhere where they're getting massive changes just because of the environment. Whereas if you live in the ocean, nothing changes. Seawater doesn't change unless you live right near a coast where there's a lot of fresh water coming in. Those fish just butter off. And those fish, most marine fish, especially from coral reefs, are very intolerant of water quality changes. That's one of the reasons it's so much harder to keep a reef tank or a marine tank at home than it is a freshwater tank. And I will never ever keep a reef tank at home because it's a pain in the backside. But that's why. So our rainbow trout generally are pretty tolerant of water quality changes because of the environment they live in. But of all the freshwater that fish, they're the most sensitive to changes like that. So generally they live in streams that don't have massive fluctuations in water quality. And the one thing that I never did when we were doing water quality testing, I was never brave enough to collect samples when this thing was raging, because that would be really interesting to look. When there's that much rainwater coming down here, what is the chemistry of that creek? I wasn't getting anywhere near that to do the sampling, but it would be a really, really neat thing to be able to figure out how to do. But the pH is important because it gives you an idea of the buffering capacity of the creek. That means that if you have more buffer in there, like calcium carbonate, sodium bicarbonate, calcium carbonate, the pH becomes much more stable. So if water is coming up from, like say you've got a well or an artesian spring or something like that, and it's coming through limestone, that water is going to have a lot of calcium carbonate in it, and it's going to buffer really well. So whatever happens to the water, the pH is going to be a lot less likely to change. Whereas if you're out in the desert, here, out in Borrego, and the water, your well water is coming through sand, it has no buffering capacity, so the pH shifts wildly. When the first farm I worked for, the hybrid striped bass farm, they had their culture facility was out in the desert, and I'll flip to hardness because this actually goes with alkalinity and hardness. Alkalinity and pH go hand in hand. If you have high alkalinity, you're generally going to have a higher pH, and that pH is going to be much more stable because that hardness is buffering, preventing the pH from shifting a lot. It's going to, most of the pressure in water is acids, so it wants to drive the pH down. So that calcium carbonate is what buffers the acids that come in, and that prevents the pH from shifting too much. So typically hard water is around 200 and up. If it's less than 200, it's kind of moderate, and then below like 50, it's really soft. Out in the desert, they had a hardness of 8. So when that water went into a fish tank, the pH would just go all over the map. So they actually had to pump calcium carbonate or sodium bicarbonate into the system to buffer the pH. So that's where alkalinity is really important. Here, our water is like our groundwater here is actually fairly hard. So we're lucky, we do have some buffering capacity. And the trout tend to like harder water more. I mean, optimum of 10 to 400, I would say it's higher than that. That's from the book. Just in my experience, it's better if it's higher. Now the interesting thing too is for your aquarium at home, but even for the creek here, the activity of the bacteria, especially the stuff that's converting ammonia to nitrite into nitrate, it's very dependent on alkalinity. If it gets much below 100 milligrams per liter, it's going to affect the ability of that bacteria to do anything, to convert that. And that's going to be similar for other bacterial activity, that whatever's going on. I often think that the biofilter in our aquariums is going to be similar to what's going on in the mud and things in a creek or a river. It's more like magic than it is science. There's just so much stuff that we'll never understand what goes on with the bacterial populations that are out there. I mean, you can get somebody sets up in an aquarium, if they do a good job in establishing the ecosystem of that aquarium, they're almost bulletproof. Whereas you can have somebody else that abuses the system, doesn't allow it to establish properly, and their fish are dying all the time. And they may start off with the exact same thing. So it is kind of magical what happens when these filters or these ecosystems get set up correctly. And you know, that's one of the problems when you've got a lot of pollution coming through. It's going to have a really negative impact on the ecosystem, not just of the fish, but the bugs and the bacterial populations that are living out there. And without all of that in harmony, it's hard to have a good stable ecosystem. And then of course temperature. So we did measure temperature when we did our sampling, but for a few years we also had these, they were called hobo temps. They were deployable, and you would stick it in the creek, leave it in there for 6 months, and it would take a reading every couple hours. And then we downloaded that data. But we couldn't put them in for the entire year, because if one of those big rain events came along, you went bye-bye to your hobo temp. Even if you we used to use stainless steel cable with swages to lock the thing in, and we'd go back and it was gone. I mean, the power of the water is remarkable. So again, you know, temperature is important for the trout, as I was mentioning before, because they're not usually warm water tolerant. Now our southern steelhead tends to be a little bit more tolerant of water temperature. And luckily, in all the years that we were measuring the water around here, and we were just doing our spot temperature readings when we were taking the oxygen levels, I didn't see anything that looked like it might be too high for the fish, especially when you got downstream. Yeah?
You've obviously got real variation in temperature from the surface water to the deep pools. Where did you take your temperature?
We did, where we sampled the water from.
I mean the depth.
Well, there's not really that many deep spots that you would get a real gradient in. I think we never went north of Country Club.
Right.
And that giant pool that's north of Country Club, that would have an effect on temperature, because we did notice that we would test the outfall where it would come through, and you know that little sluice that goes down. We would sample from there and we take the temperature from there, and that was always like the warmest. As we went downstream, it was cooler. And there aren't any areas as nasty as that pool above Country Club all the way down. So and the fish can migrate to where it's optimal as well. So you know, if it was too warm in one spot, they could get lost and move to somewhere that was more suitable. But I think that was the only spot up there that I ever saw any temperatures that I thought might be concerning. And I think now it's changed. There's more overgrowth and things now, too, with the trees and things that have been growing. So it'd be interesting to see. I think that's it. Fish and water go together really well.
Thank you. That's fine. Anybody have any questions? Yeah.
So could we reintroduce this other steelhead trout in Escondido Creek, barring if we could get rid of all the obstacles?
I think we could. I know they say there are a few obstacles. I think we could put fish in the creek.
No, I mean obstructions, the damming of it.
Yeah, I think we could. I think that personally, if we stocked fish in here, we would develop a resident population that not necessarily would be going to the ocean. I think during flood events, they could get to the ocean because all of those barriers, the water's just flowing over them. And it's amazing what a rainbow trout can swim up. I mean, it's just remarkable. I remember when I was much younger in university, I was sampling fish in rivers for a disease project. And my buddy and I, we'd have this giant seine, and we'd be walking through this river, and it was flowing really hard. And these fish would just go, they would take off upstream like there was nothing. So these rainbow trout, they can swim up whatever nature provides during those heavy rain events. But even besides that, we could establish populations in the creek, I think, easily.
And the 20-degree centigrade that you had on there as the high point?
Well, that's for all rainbow trout. I think the steelhead are more tolerant. I think they can take 25 to 30.
Which is converted to Fahrenheit?
75 and higher they can take.
So Ariel, we're getting, those are,
Yeah, we're
all
getting
our
about
temperatures
that,
are below.
Yeah.
The coastkeeper data shows that sometimes it does pop above 75.
Yeah, and that's what I remember too. When I don't think, the only time I ever saw something above that was at Country Club in the middle of summer when that pool was baking. It's the only time that I thought there was some temperatures that weren't conducive.
So reintroducing the steelhead, would the main benefit be adding biodiversity to the area? Like I hear salmon are great for biodiversity because they decay and they feed the forest and all
That's
that.
the Pacific salmon, yeah, when they die off. The rainbow trout, they don't die off after they spawn. They'll reproduce multiple times. Actually, our biggest problem is the bass and the green sunfish. I caught a bass under there, it was this big.
I've seen them pretty big.
Yeah, they'll just eat every steelhead we put in there. So the creek has to be purged of those guys too, that's a huge issue.
So the benefit is the biodiversity that they would bring to the area? I mean, along with the beauty and enjoying seeing steelhead in your creek.
Bringing native species back, because the bass and the green sunfish are not native. I mean, there's other, arroyo chub is another native species which would be interesting to work with and bring back. There's a native stickleback too that used to live around here, which I don't know if it even exists anymore. It would be, you know, the way we're trying to conserve other areas and bring back native species, I think that's kind of the idea for the entire Southern California with what the, sorry.
No, go ahead.
One more little.
Yeah.
There is a, The California government has sponsored with NIMS and NOAA a huge steelhead rehabilitation program. And they're looking at all the creeks within the steelhead's range to the Mexican border. And they're looking at what's it going to take to rehabilitate these streams to make it so that steelhead could survive in them. And they spent $2-3 million on this over 10 years. It sort of drove me crazy. It's like he could have saved a lot of steelhead for $2 million. I'm sorry, but and I used to go to all these meetings, and I used to fight for the creek. I wanted it to be included into this document, but I got yelled at one time that they weren't going to do it, and they told me to shut up, essentially. So, but unfortunately, because our creek is the only one that actually flows all year. But it takes support from these guys because they're the ones that, they're the folks that have to come in with the electroshockers and the rodent gnome to get rid of all the non-natives. So there has to be cooperation with the California Department of Wildlife because they're the ones that have to do that work. So that's the tricky part. The barriers are much less of a problem. It's the largemouth bass and the green sunfish that are the big problem. Bullfrogs too.
There might be another problem. I recently came across an article, or actually John did, I think, about an entire additive that converts into a chemical called CPPDQ, and they tested 4 different fish to find out how toxic it is for fish, and trout was one of the ones that was, it was very lethal for the trout. I think the LC50 was 0.1 milligrams or micrograms per liter, and the trout was really sensitive to that. And the statement was, no, it was not, they tested it in different, it was not done here, but they tested 4 different fish, and the steelhead was one of the sensitive fish, and the statement at the end was that no restoration would be successful if that chemical is in the creek water. So there's a petition to get rid of that additive entires, and maybe that would be a good thing to follow up with.
Is that chemical in the creek here? I've never heard.
I don't know, but it
We can assume it is.
because they tested.
It's in all automobile tires.
Mm.
It extends their life and their resistance to ozone. It decimates salmonids populations. And a recent study focused on steelhead and said it's just as susceptible as the other salmonids. It's the second most toxic chemical in watersheds. So if that still stays in the car tires.
Yeah, does it get into the mud then and stuff? I mean, I could see.
Yeah,
Runoff
it
from the
run
streets.
off from the streets.
Right.
Yeah.
Well, I'm guessing it's probably cyclical. It's not there all the time because we don't always have runoff from the roads. So
Right.
when you get a heavy rainfall, then it's probably going to be, that's when it gets washed into the creeks.
Yeah.
One of the studies they did said 100% fatality from that one chemical.
Did they test it on bass and green sunfish? Because we have a good experiment going on.
That's a good question.
I'm gonna go put 50 tires in at the headwaters of the creek.
But the EPA has the regulatory power to remove that, to get that out of the car tires. There's a petition that's being raised by several Northern California tribes. It's been sent to the EPA. And we hope that passes because that's a huge obstacle.
I've never heard of that as being a reason for a die-off of salmonids.
It's just the past couple of years that the studies have been done on it. I can send you the article.
I'd like to see it.
So it was done in Northern California because they noticed the tribes, they depend on the steelhead, and they noticed this huge die-off.
Is that in Washington State?
Was it in Washington? It might have been. I have the article on the phone, I can show you it.
Because the Columbia River's a mess too. And that's where a lot of stuff happens in the Columbia River.
But they tested this chemical in particular in this, there was a scientific study done.
Interesting.
to test all this. And,
Yeah.
Jeff,
Do we have any historical evidence that southern steelhead were in the Escondido Creek?
That's a really darn good question, because that was one question that I was asked a long time ago, and I was told by somebody that there was, but I've never been able to find any evidence, documented evidence that there were. There is no reason to think there wouldn't have been, because every stream along this coast has had steelhead in it. Anything that opens up to the ocean is a prime target for steelhead. So I don't see any reason why they wouldn't have come up the Escondido Creek. And they're very different than other salmonids. Like most salmon and trout, if they go to sea, they come back to the river they were spawned in. But because Southern California is pretty messed up with its rivers opening up to the ocean, they're more opportunistic. They'll find the one that's open and they'll all go up that one, or the one or two that are open that year. So the fish aren't really restricted to one stream. And this was one of the crazy things one of the things that the Department of Fish and Wildlife was very interested in was looking at the genetics of steelhead from different watersheds. And they were saying that if they were different, you wouldn't be able to put steelhead from one watershed into another one. And it's like, they're opportunistic fish. They're going to go out whenever stream is open. And if there's no steelhead in this one, why would you not take this genetic strain and put some over here? Because guess what happens in a few generations? They're going to evolve. You want to get steelhead back in Southern California, and you have a very small genetic pool to work with. That's what you got. That's what you got to kind of work with and get things back to where they were. I didn't have a very good experience with the Department of Fish and Wildlife.
Do you have any reason to think why they may not be supportive of that sort of idea?
I have no idea.
Yeah.
I really have no idea. I think it's because it wasn't on their list that they started with, and they were pretty
Adamant?
I know, I did get some support from one. There was this one woman that managed northern steelhead. There's like a northern steelhead conservation group that she was with the Department of Fish and Wildlife, and she was actually really good. She came down here, and she was supportive of it. I said, well, what if there's some barriers? She said she'd come down here with dynamite. I mean, she was great. But once it got to the upper echelons, and it was actually a guy from NOAA, from NIMS, he was the one that was really obstinate and mean.
Well, people come, people go.
Yeah, unfortunately he's still there. I know he's still there.
All right, well, thank you so much, Paul.
All right.
If you want to know anything more about the Interpretive Center, Elfin Forest, Conservancy, feel free to stick around for a minute and chat. But otherwise, please grab some snacks and drinks on the way out. Thanks for coming.
Thanks.